Hello students, welcome to my channel. This video lecture is mainly for B.Sc Mathematics Honours. This is my third lecture from the chapter Integers or Number Theory, taken from the blog Classical Algebra. In this video, we are going to solve a problem applying the principle of mathematical induction. So let's get started. Okay. So here is the problem. Prove that 3 to the power 2n minus 8n minus 1 is divisible by 64 for all n belongs to n. That is, for all natural numbers n. Okay. Now let's look at how to prove this. We have to prove 3 to the power 2n minus 8n minus 1 is divisible by 64. This is a statement involving n and we can call it Pn. Let Pn be the statement 3 to the power 2n minus 8n minus 1 is divisible by 64. Here we use double quotation marks for the statement. Okay. Now for n equal to 1, 3 to the power 2n minus 8n minus 1 equal to, what will we get here? For n equal to 1, 3 to the power 2n minus 8n minus 1 equal to what? 3 square minus 8 minus 1. 3 square minus 8 minus 1 equal to 3 square becomes 9 and minus 8 minus 1 becomes minus 9 equal to 9 minus 9 becomes 0. Okay, which is divisible by 64. For n equal to 1, 3 to the power 2n minus 8n minus 1 equal to 0 and 0 is divisible by 64. So 3 to the power 2n minus 8n minus 1 is divisible by 64 for n equal to 1. That is, the statement Pn is true for n equal to 1. That is, P1 is true. Therefore, P1 is true. Okay. Let us assume that Pk is true where k belongs to n. Let us assume that Pk is true where k belongs to n. That is, k is a natural number. Then Pk is true means 3 to the power 2k minus 8k minus 1 is divisible by 64. So we have 3 to the power 2k minus 8k minus 1 is divisible by 64. Okay. Therefore, 3 to the power 2k minus 8k minus 1 equal to 64 into, what can we write here? 3 to the power 2k minus 8k minus 1 is divisible by 64 implies 3 to the power 2k minus 8k minus 1 equal to 64 into what? We have to know what is an integer. 0 plus minus 1 plus minus 2 plus minus 3 dot 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 are called integers, and the set of all integers is denoted by z. So z equal to this. Here 1, 2, 3 dot 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 are positive integers, also called natural numbers, and minus 1, minus 2, minus 3 dot 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 are negative integers. Okay. Now 6 is divisible by 2, and we have 6 equal to 2 into 3. That is 6 equal to 2 into some positive integer. Again, minus 12 is divisible by 4, and we have minus 12 equal to 4 into minus 3. That is minus 12 equal to 4 into some negative integer. So a is divisible by b means a equal to b into some integer. Since 3 to the power 2k minus 8k minus 1 is divisible by 64, therefore 3 to the power 2k minus 8k minus 1 equal to 64 into some integer, say m. So we have 3 to the power 2k minus 8k minus 1 equal to 64m. For some integer m, that is m belongs to z. Okay, let's say this is number 1. Now putting n equal to k plus 1 here, we get 3 to the power 2 into k plus 1 minus 8 into k plus 1 minus 1 equal to, we are going to use the principle of mathematical induction. We have shown that P1 is true and assumed that Pk is true, where k belongs to n. So now we have to check whether Pk plus 1 is true, that is whether this is divisible by 64. Okay. Now this is equal to 3 to the power 2k plus 2 minus 8k minus 8 minus 1 equal to 3 to the power 2k plus 2 becomes 3 to the power 2k into 3 square minus 8k minus 8 minus 1 becomes minus 9 equal to 3 square becomes 9 into 3 to the power 2k minus 8k minus 9 equal to 9 into, what can we write here in the place of 3 to the power 2k? Notice that from 1 we have 3 to the power 2k equal to 64m plus 8k plus 1. So here in the place of 3 to the power 2k we can write 64m plus 8k plus 1. 64m plus 8k plus 1. Okay, minus 8k minus 9, and this is obtained using 1. using 1. This is equal to 9 into 64m plus 9 into 8k becomes 72k plus 9 into 1 becomes 9 minus 8k minus 9 minus 8k minus 9 equal to 9 into 64m can be written as 64 into 9m. 64 into 9m plus 72k minus 8k becomes 64k, and 9 minus 9 cancels, 9 minus 9 vanishes. This is equal to 64 common, 64 into 9m plus k. Okay, now notice that here m is an integer and k is a natural number, that is a positive integer. Hence 9m plus k is an integer. So we have 64 into some integer, which is divisible by 64, since 9m plus k is an integer, that is 9m plus k belongs to z. Okay, so 3 to the power 2 into k plus 1 minus 8 into k plus 1 minus 1 is divisible by 64, that is pk plus 1 is true. We assumed that pk is true where k belongs to n, and now we see that pk plus 1 is true. Thus pk plus 1 is true if pk is true where k belongs to n. Okay, so we have shown that p1 is true and pk is true implies pk plus 1 is true where k belongs to n. Clearly, the two conditions of the corollary of the first form of the principle of mathematical induction are satisfied. This is the first condition and this is the second condition. Therefore, by the principle of mathematical induction, what can we write here? Pn is true for all n belongs to n. That is, Pn is true means 3 to the power 2n minus 8n minus 1, 3 to the power 2n minus 8n minus 1 is divisible by 64, and this is true for all n belongs to n. For all n belongs to n. Okay, this completes the proof. Now notice that here we have applied the corollary of the first form of the principle of mathematical induction, but we can simply say that by the principle of mathematical induction or by the principle of induction. Okay, if you haven't watched the video of the principle of mathematical induction, please watch it from the above I button so that you can understand this proof perfectly. Alright, so that's it. If you have any questions, you can ask me freely in the comment section and I will definitely try to answer them. If you like this video, please click on the like button and also subscribe to my channel for more videos which are important for B.Sc Mathematics Honours exam. And don't forget to click on the bell icon that will give you notifications when new videos come out. So thank you so much for watching and until next time.